and okay. Hi everyone, my name is Lauren and I study the biogeochemistry cycling of metals in river systems, and behind me is the Earth Scientist periodic table. And fun fact about me, this is my favorite periodic table of all time, so I like the Earth Scientist one. That one's my favorite. So my question to you all, and I'm going to stop sharing my video, so I'm just going to pop away. So my question to you all is, have you ever looked outdoors and wondered what's in this? And if you have, then that would mean you've sort of wondered about the field of biogeochemistry. And so what is biogeochemistry? Biogeochemistry is the combination of biology, so study of organisms, geoscience, so studying the earth processes, and chemistry, which can be anywhere from, analytical, physical, biological, so biochemistry, and organic, inorganic, and sort of combining those three fields into one field. And so what I particularly do is biogeochemical cycling. I sort of track how metals are in different concentrations and moving throughout river system environments. And so biogeochemical cycling is basically how are things moving from, from the geological component through, water through into the atmosphere, through the trees, plants, vegetation, biological organisms that are in a water body. This is kind of everything that I do as a biogeochemist. And so for me, I'm going to talk about metals in freshwater because that's what I know. And so metals can be introduced through weathering, through volcanic eruptions, through human activity. And examples of metals include arsenic, cadmium, chromium, copper, nickel, lead, and mercury. And metals cause environmental damage, and benthic organisms, which are organisms that live on the bottom of a river system or any water system, are the most affected. And so my question is, how do we even track metals in a river? So one thing we have to do is do field work, and so I collect water, sediment, mussels, and lichens, and that's just to be able to look at everything. Lichens are really good about looking at atmospheric input, so that's why I look at lichens. And I also do field work in the summer and winter. And why? Why would I do that? And one reason is because water temperature influences aquatic life and water chemistry. So that means that I would expect to see changes in metal concentrations in summer and winter conditions. And so warm temperatures dissolve more minerals and increase electrical conductivity, which decreases the pH. And so electrical conductivity is a measure of the total number of ions you have in your water. And so pH is based off of the hydrogen ion, H+, and so by increasing electrical conductivity, pH is going to decrease because we're going to have more H+ ions present in the water. And there's also less dissolved oxygen, so there's less oxygen available in the water. And then in cold temperatures, we're going to increase in dissolved oxygen, we're going to increase in CO2, and we're going to decrease in electrical conductivity, so there's going to be less ions present in the water in general, which is going to increase our pH, which means we're going to switch to be more basic. And so field work, we sample summer and winter time just because there is less water available in the particular river that I study in the summer than in the winter time. So this is the exact same spot, summer, winter, and we have no water, and here we have water. And also doing field work in summer and winter time, because at least for the river that I study, in some periods it's more of a gaining stream, and in other periods it's more of a losing stream. And so this video kind of illustrates the difference. So gaining stream, the surface water will be helped to be filled with the groundwater. So we actually have groundwater contributing with the surface water. And then in losing streams, we have surface water is replenishing the groundwater. And so we have these groundwater surface water interactions that we also want to consider when looking at these metal concentrations and their cycling. And then also do lab work. And so what I do is, this is kind of a TikTok video that I made about lab work, but I basically dissolve samples and put them in digestion tubes with various different acids, depending on the method that I'm following, and put them in a sample holder that is acceptable for a microwave. and I microwave them. And this is not an at-home microwave, this is a lab-grade microwave. And then wait for them to cool off, pour them out into these tubes, and then dilute them for analyses. So diluting sample, and then I'm going to run them on the instrument that we utilize. And once they've been run, it will tell us the ICP-MS, which is inductively coupled plasma mass spectrometer. It'll tell us how much of a metal or whatever element of interest that we're looking at we have in our sample. And so that's kind of back to biogeochemical cycling is, just trying to figure out how things are moving throughout the environment. And in particular for me is looking at how metals are moving throughout a river system and what that means in terms of human health, aquatic health, river health, and what that also means in terms of a changing climate, how that's going to impact those concentrations.